Hello all, I hope you all are doing well today. My name is Andrew Guest, and I am presenting augmented reality activities at the Center for Geospatial Research. We are part of the Department of Geography, and I'll be showcasing the work done at our Disruptive Geospatial Technologies Lab, or Digital. The underlying system of our lab is the 3DIG system, 3D Immersion and Geovisualization System. These four components, image acquisition, virtual reality, augmented and mixed reality, video displays, all work together to produce geospatial data. For example, a drone can capture buildings using structure for motion, create a 3D representation of those buildings, and display it in an augmented or mixed reality environment. It could also be displayed in a virtual reality environment, and it obviously can be displayed on displays. This shows interconnectability of this 3DIG system and the brilliance of it. Speaking of augmented reality, I'd like to talk about AR Globe. Our goal of this project is to provide interactive globes in an AR environment. We would like to present multiple concepts in geography with this application. For example, we can display the physical Earth, sea temperature of the Earth, and other data that may be helpful to represent. In this day and age, infection rate would be a very helpful statistic to display. Here's the application being run on an iPad. We can also select different displays of the Earth based on month. Currently, we are working on porting this project from Apple-based to be supported by both Android and Apple using the Unity game engine. The photo on the right is AR Globe in a Unity environment. And also here is the sea surface temperatures in AR Globe. Moving on to the next AR project is the Augmented Reality Sandbox. The sandbox works by having a capture device above a sandbox. We use an Xbox Connect. It generates an elevation map from the sandbox and then projects features extracted from the elevation map onto the sandbox. The sandbox is very helpful for research as it is near real time and used for many what-if scenarios. Here are some more photos. We enhance the augmented and mixed reality experience by adding virtual elements to the sandbox, such as contour lines or altitude lines and liquids. Check out this animation of the sandbox in action. As you see here, he's moving the sand around and he's changing the contour. And then he puts his hand over the sandbox and it starts raining. And you can see the liquid. How cool is that? Here's a project that I started working on when I first arrived here at CGR. My goal is to integrate a wind simulator into the tangible sandbox. The simulator extracts an elevation model from the sandbox or from user reference, converts the model to 3D terrain, runs a simulation, and then drapes the wind vectors over the sandbox. The simulator can provide a simulation in just a few minutes, which is very impressive for a simulator. Simulation is a complex problem, and weather simulations are usually done on supercomputers. Here's a graphical example. As you can see, here's the sandbox and the cameras, and it's going to pull the data, run it through the computer. Computer does its simulation, its magic here, and then the wind vectors get draped right on over it. Here's a maximized photo of the Mount St. Helens simulation with a reference photo of Mount St. Helens. See? And this is after the eruption. So this is the physical photo. Here's a simulation. As you can see, it's wind vectors go around the peaks of the mountain, or the volcano, I mean. Here are some more simulations. The photo on the left is a simulation from a hill in Wyoming. The photo on the right is a simulation of Athens, Georgia. Right here, there's a river, and you can see the wind kind of flows through the river as it's a gap in the hill, you know? We can integrate all our technologies to create a comprehensive AR and VR experience. We can use a drone to recreate buildings into a 3D object, represent them in a 3D world, make that 3D world compatible with VR. Pretty cool, huh? I'll be going into our other projects. The tangible landscape allows us to incorporate many activities for demonstrations of concepts and processes in the earth sciences. For example, an activity would be guided terrain building, where the landscape would guide you to build terrain using colors. For example, the color white means the terrain is on level, no more sand needs to be added or removed. I've already hinted about some of the 3D reconstruction efforts. Cobb's World is a project used to reconstruct some of the historic buildings in Athens, one of them being the Cobb House. We fly a drone over the buildings to capture the structures from motion into a detailed 3D object. Our goal is to represent the buildings as it would have been seen in the 1850s. So these blue squares here is the path of the drone. And we actually fly over it multiple times since we need to capture the angles of both buildings. So we would go this way and then this way, because if you only flew a drone above the buildings, you couldn't get the walls. And obviously the structures and 3D models that are produced by the drone are very detailed, as you can see here. And this statue, in the grand scheme of things, is pretty small. It's about the size, it's about over here. We are collaborating with the Department of Psychology here at UGA to merge geovisualization and digital technologies with the science of human psychology. The acrophobia simulation project is essentially a game where the participant is in a VR world and has to fight their fear of acrophobia. You know, this could be a tightrope, it could be a bridge, etc. As you can see here, it's basically a game. Another project that the collaboration has worked on is simulating the different levels of colorblindness here. So this is normal, and these are the other levels of colorblindness here. Let's go into some of the applications that our lab offers. Here's the statistics of our lab. We have over 6,000 individual interactions, 55 courses and sessions we have participated in, 13 events, and 22 student developers. Here's an image of our assistant director, Sergio, showcasing the AR globe in the classroom. Here's a showcase of the sandbox to a group of students learning for their geography class. It serves as a great learning aid to students. Believe it or not, this is how I first met the center. Overall, one of the biggest missions here is to enhance teaching and learning with disruptive technologies. So we're using, virtual reality in the classroom. We have the sandbox pulled into the science library, and then Forest Service here with also the virtual reality headset here. Pretty cool, huh? We would like to thank the Center for Teaching and Learning at the University of Georgia as they have funded the lab. Thank you all for watching this presentation for GIS Day 2020. I hope you all enjoyed the presentation. Please visit our website if you wish to learn more. And also let me know if you have any questions. Have a good one. Bye.